what if we have multivariate data, which happens quite often, of course. So we had our example of this wire bond data. So we have a wire which is connected to something, and we're asking ourselves how well this bond is made. So we have these 25 observations and three values for each observation. And so we can then plot the data in different scatter plots. All right, so that's one way of doing it, and you can see that also here we've, or it has been indicated what the box plot would look like for the data. So this is the box plot for the length, right, and this is the box plot for the strength of the data set. Okay, so that's also a way of doing it. We can look at correlation coefficients. So this is the definition of the correlation coefficient. Sxy is given here. It's a summation of the product of the distance of data point to the mean for that observation value for the x data set, for the y data set. This is given here. So we're looking at the correlation between x and y. And so by making these products and summing it and comparing it to the variation in the x and the y, we can see what the correlation is between x and y by making this ratio here. Okay, and this is something which you can also do, of course, by looking at scatter diagrams to see if there's correlation. So you can do both graphical and by doing this calculation. The calculation obviously has the advantage of giving you a quantitative value, but it's always good to also plot your data. Why? Because, of course, you can see here there's correlation. Positive correlation, negative correlation. Here there is no correlation. But if you would look at this one, there is also correlation. But with the correlation coefficient, you would still get something which is close to 0. So it's good to also always look at your data as well, even if you have large data sets. Because you may see things which you don't pick up with the mathematics that you're throwing at it.